This little study came across just after the last update evening, and it's from the Far East actually. It's a fairly recent study done about 18 months ago, where they looked at this idea of mindset, your mental attitude to things, and to do with the learning of science. And what they did was to get 3 groups of students, quite large groups of students. So you can see there, these aren't just random results they've got, getting on from the 300 students involved. Group 1 did their ordinary science, but they did it as well by learning about the people who were actually made the discoveries. So if they're learning about Boyle's law, they learnt about Mr. Boyle and where he lived and what he did, and the difficulties that he had, the problems that he had, the setbacks. Obviously any great scientific discovery is very rarely there's gravity, there's problems, there's confusions, there's mistakes, things like that go on beforehand, and this was built into their education. So they did the science, but they also did the people behind the equations, the people behind the famous laws and so on. Group 1 with the control group, they just did ordinary science, and group 3 are sort of in between. They did ordinary science, but they learnt some of the names and some of the dates. Now, the results are really interesting. The first 2 you could kind of guess. They obviously did some testing of those students afterwards on identical material, and the first 2 are no really great thing. I must admit, since I first started teaching, including when I'm teaching boring old physics, to try and put in a bit about the people who discovered the physics, because it just makes it more interesting, makes it more human, and more people are interested in it. So I really wasn't surprised by the second one. I thought, I know that. It's the bottom 2. The students actually remembered the science better. So they didn't just score better in tests about, do you know which scientists discovered this? This is the extra stuff they've been taught of. In a side-by-side with a control group test of just the science, full stop, they're actually better, significantly better. And the bottom there, when they were given more open-ended, more difficult problems, more higher-order problems to do, they performed better in the control group. And that just struck me because there's no obvious reason why they should. Obviously, they probably would have a better interest in science, that's kind of obvious, but the other 2, there's no obvious reason for that. And it kind of stuck with me. I've always tried to include scientists when I teach about physics, but I've done it for the second reason. Maybe actually doing that helps students to actually get higher marks, which at the end of the day is obviously an important thing. I know very little about how the brain works, but I'm thinking perhaps there's an area of your brain that deals with people. I imagine in most people that's going to be quite an important area. Part of your brain that deals with other people and stuff. And the part of your brain that deals with... This is a view of the brain that went out in about 1500, but bear with me. The bit of your brain that works with physics, those of you who didn't like physics at school, I won't ask you to raise your hands. Stop it. The people, if you think about the part of your brain that works on physics, it's often quite a remote part. It often seems quite distant. Presumably what this is doing is it must in some way be linking the bit of your brain that works on physics, which can be quite isolated, to the bit of your brain that works with people. And as far as I understand it, the brain's all about links. And if you can start to make that link, anything that you learn in the context of people, don't know. It's very recent research, but it suggests that may be the case. Okay. Now, in the interest of science, I decided to experiment on my Year 7s. It didn't do too badly because they made it through to Year 8. So I tried some of these ideas out with my Year 7 class from last year, with mixed results, which they're going to tell you about.
Archimedes, as you all know, discovered density in his bath. Next, James Joule. James Joule was a scientist from Manchester who discovered heat was not a magical liquid, but actually a form of energy. He discovered this by putting water in a barrel and stirred it. Surprisingly, it heated up the water. Jeremiah Horrocks, the scientist from Preston, was the first person to discover ambiguity transit of Venus. His discoveries allowed scientists to discover the size of the solar system. Isaac Newton discovered the physics of gravity, motion and light, but he did have a human side as well. He spent most of his time arguing with other scientists.
My speech is about Eratosthenes. He was a Greek mathematician who lived in the 3rd century BC, and he's possibly the most remarkable man we've ever heard of. Never heard of. He was also a geographer, musical theorist, chief librarian at the Library of Alexandria. He was the first to calculate the tilt of the Earth on its axis, the first to invent a globe using parallels and meridians, but is probably best known for calculating the circumference of the Earth to a remarkable degree of accuracy. He did this by looking at shadows cast by the sun without leaving his hometown. He was aware that on Midsummer's Day there were shadows cast by the sun in Alexandria, but there were none in Syene, modern-day Aswan. He knew that when the sun was at its zenith, at local noon on Midsummer's Day, it shone directly down a deep well in Syene. This we now know to be on the Tropic of Cancer. At the time, he lived in Alexandria, and as Egypt was well mapped, he knew accurately how far it was from Syene to Alexandria. On Midsummer's Day in Alexandria, he mounted a stick vertically in the ground, and when the sun was at its zenith, he measured the angle of the shadow cast by the stick, and found it to be 7 degrees and 12 minutes off the vertical. He assumed that the Earth was a sphere, and that Syene and Alexandria were on the same meridian. Using this, he calculated that this was an arc of 1/50th of a circle, and thus 1/50th of the circumference of the Earth. He multiplied the distance from Alexandria to Syene by 50, and came up with the number of 252,000 stadia, which, translated into modern measurements, gives a result with a maximum error of 16%. Pretty good going using a stick and intuition. 1,700 years later, Christopher Columbus sailed to the West Indies. While he did read the calculations of Eratosthenes, he chose to believe another opinion, that the circumference of the Earth was much smaller. Had he believed Eratosthenes, he would have realized that he had not landed in Asia, but in a new world.
Thank you, Laurie. So now we come on to the positives and negatives about how Mr. King taught us last year in Year 7. So, when we learnt about the scientists who did the research on the topics we learnt about, we understood and remembered the facts more easily. And it also made the lessons a lot more interesting when we learnt about the scientists behind all the findings. And also, we now have knowledge of the researchers of the topics we learnt about, as well as the facts. And then there were, well, a negative, and that was, when it came to tests, we were unsure whether we had to revise about the scientists as well as the facts.
So, as mentioned before, designing questions helped us quite a bit because it put us in the shoes of the exam maker's questions and really helped us get behind the questions. And then we gave each other our questions and did them and marked them. This mixture of designing questions, marking questions, and thorough assessments helped find the flaws and helped us in exams. But also helped us with the extra projects we took part in, which really helped us gain knowledge, as they were fun to learn about different pieces of trivia. Like, for example, the most common theory on the Hindenburg disaster is that when the Hindenburg blew up, it was due to the hydrogen catching fire. But in fact, if this was the case, in fact, the hydrogen had already left by the time it had split. It was in fact the static electricity built up from the long journey that set fire to the